Find something of value.
A higher education community in South Africa reflecting on intellectualization.
How central this humanity is.
It's April 2025, and I have no real idea what I'm about to get into. I have about 5 days, including a weekend, to get my affairs in order before I board the SA Agulhas II, the national scientific research vessel belonging to the South African government, and by extension all South Africans. I must check in with colleagues and reorganize work schedules. I have to find doctor and dentist appointments so that I can submit a full medical clearance. I have to figure out what to pack for over a month at sea. And not just any sea, the ice-cold Southern Ocean. I have never been on a big ship. I've only ever been on small boats that have stayed in sight of land. I didn't even know where the SA Agulhas II is moored when it's not on voyage. It's outside the Department of Forestry, Fisheries and the Environment warehouse at the East Pier, all the way past the V&A waterfront in Cape Town. If you search for it on Google Maps and put it on satellite view, you'll see the ship in its berth. I'm so busy getting all my ducks in a row that it feels surreal to feel myself in the autumn sun, waiting with 2 kit bags on East Pier, in front of this big red ship, marveling at its hulls and 8 decks. The icebreaker before me is picturesquely framed by Table Mountain in the background. We're due to set sail that afternoon. This ship will be my home for 33 days. Our destination? Marion Island, South Africa's subantarctic territory at minus 46.88 degrees latitude and 37.87 degrees longitude. That's basically halfway between our southern coast and Antarctica. Welcome to The Academic Citizen. I'm your host, Mehita Ikani, and I'm so pleased to be back with this special season, recorded on that voyage in April and May 2025. I got a last-minute opportunity to represent the South African National Antarctic Programme's Artist and Writers Project, which was devised and is run by Professor Charne Lavery at the University of Pretoria and Professor Brundrit from the University of Cape Town. Their chosen writer could not make it at the last minute, and the only possible replacement who could wing it in their crazy life schedules was, yep, you guessed it, me. So I went. And this podcast season is one of the things I created from that residency. Over the next 4 episodes, I'm going to introduce you to some of the scientists doing research on Marion Island and from the SA Agulhas II. You're going to hear about the plants, animals, and birds from that little piece of land in the Southern Ocean. And you're going to hear the voices of seasoned researchers who have been working on Marion Island and in the Southern Ocean for decades. And you're also going to hear from those who are just starting out in their scientific careers. I'm so happy to be able to share some of the voyage with you, and I hope you'll come along for the journey. So, metaphorically speaking, grab a woolly beanie, a pair of gloves, maybe a set of thermal long johns, maybe some cozy socks. Take a deep breath of wild sea air and walk up the gangway with me.
Spending time on this ship or on the island with all these amazing scientists and people around you, you don't really get that anywhere else.
I remember we had a huge storm. It was life-threatening. I've never experienced in my life when the ship goes high and then come and crash and then the water covers the whole. So from that trip, I said, no more. I'm not setting my foot again. But come next year, I was on the ship coming down because the island has become part of myself. It's like a second home.
Before we get to Marion Island, though, you need to meet this ship, the SA Agulhas II. As I've already noted, this is our national scientific research vessel, an icebreaker, designed to carry out research and supply to the South African research stations in Antarctica and the subantarctic islands. The Agulhas II is 134.2 meters long. It's a Polar Class 5 vessel with a crew of 45, space for 100 passengers, in very comfortable cabins. It has a gym, a library, huge cargo holds, a hangar for 2 helicopters, and much more. If you're a ship nerd, there's loads of technical information about this ship on the South African National Antarctic Program website. And we've put the link in the show notes, so you can check that out.
Yeah, I would say the Agulhas is now she's now 12 years old. She was 12, 13 years old, 2011. She arrived and built in Finland. At the time, she was state of the art. And we've, over time, updated systems to maintain her at that status.
Every year, the SA Agulhas II has open days in different cities around the country, obviously coastal cities only, where the public can visit the ship. So if you're interested in that, also keep an eye on the SANAP website. It's a really cool opportunity to take the family, take the kids, and go and have a tour of this incredible ship that belongs to all South Africans. One thing that's really interesting about this ship is its huge scientific capacity. It is basically a sophisticated floating oceanographic laboratory, and it has loads of really high-tech instruments.
So yes, it's a valuable asset to us, especially doing work in the Southern Oceans.
Let's find out more from Marcel van den Berg, the chief ship-based scientist on the Marion 2025 voyage.
Yeah, we've got some very technical equipment. All these instruments take a lot of effort to maintain, hence the technical people on board.
For our voyage, Marcel was in charge of all the scientific work that took place on and from the ship. And he has had a long career of seafaring in service of science as a member of the Department of Forestry, Fisheries and the Environment.
I've been here a few years. So I'm in charge of all the equipment on the vessel, seeing that they're operational, that we use for our research.
If you ever run into him, he will definitely have some really interesting and excellent stories to share about the many expeditions on scientific vessels that he has taken over the years. But let's focus on this particular ship, the SA Agulhas II. What kind of science can it do?
The main instrument that we use is our CTD, which we use to collect real-time profile data and water samples.
A CTD is an instrument that gets deployed off the ship into the ocean to measure connectivity, temperature, and depth.
And on the CTD, we've also got additional instruments that measures barometer, backscatter, how much plankton's in the water.
The sensors that record the data are small devices that are attached to a pretty big cylindrical rig, which also has 25 long bottles all around the circumference of the rig. And these bottles can trap water from specified depths as needed by the scientists on each deployment of the CTD.
Okay, so the CTD consists of a underwater unit that's rated to about 7,000 meters. And when we do a station, the CTD goes down at 1 meter per second. The data gets fed back to us. And then from there, we can determine where to collect water samples.
On the SA Agulhas II, the oceanography lab is on the 3rd floor of the ship, so it's basically at sea level. And it has a big outside wet deck where a lot of deployments happen, as well as several labs on the inside. The CTD is winched overboard by the crew of the SA Agulhas, who are these very, very experienced operational, technical crew members. And it's winched overboard either from a really big hatch on the side of the interior oceanography lab, or less often through something called the moon pool, which opens from inside the ship if the weather is too rough to open the side hatch. When I was on the voyage, I was lucky enough to see the CTD getting sent down and brought back up from the side hatch. It was pretty cool. The CTD sends data that it records live up to the operations room on the ship. So as well as the labs that I mentioned earlier, there is an operations room where some of the technicians sit behind screens, tracking and monitoring all of the data that is being sent live from the instruments on the CTD. And all of that data is captured and stored for later analysis.
The operators can then see what the conditions are related to temperature, salinity, the oxygen, and then all the additional sensors that are attached to the CTD also feeds data real time.
If you're wondering, like I was when I first saw these screens, how the data gets from the CTD deep under the sea's surface to the screens of the computers on the ship, the answer is through a long conductive cable.
So the conductive cable doesn't actually send the actual values up. The instrument uses voltages to measure what's in the water. So it'll give you a voltage between 0 and 5 degrees, 0 being very low values, 5 volts being a high value. And then in the software, there's calibration coefficients that converts these voltages into actual values that would then give you the temperature, the conductivity, and from there you can calculate the salinity, oxygen, fluorescence, which gives us the amount of plankton that's in the water.
Since 2012, the Department of Forestry, Fisheries and the Environment has been running long-term longitudinal data collection in a number of key oceanographic sites, including the waters around the Prince Edward Islands. The same areas, called transects, are sampled on every voyage.
We've been doing this now for 13 years already. So now we can actually start looking at the data because we've got a long-term average to see what the changes are. All the data gets processed straight after the cruise or as soon as we can get it out. Then it gets published on our Marine Information Management System, MIMS, which is a TFE Scion initiative database system, and it's open to the public.
We've added the link to MIMS, the Marine Information Management System, to our show notes. So if you want to go and check out some of that data for yourself, you can. It's an open source database.
What we use the data for is to pick up trends. We also create indicators that we need to monitor to see what the changes are around the islands. The main thing is to see the interaction with the top predators and oceanography and the physics around the islands.
So the CTD is a key piece of oceanographic equipment that records ocean physics and chemistry and other important data. But there is another impressive piece of equipment that can sample some of the tiny life that lives in the ocean, plankton. You'll hear more about these critters later in the season. But here's Marcel explaining how scientists catch them.
The other instruments we have on board for this voyage is a plankton net. It's a vertical plankton net, which uses 200 micron mesh nets. And we do vertical profiles on the same stations we did CTDs to identify species and to do biomass volumes.
Biomass volumes mean that oceanographers check to see how many living organisms, basically different kinds of plankton, are present in the specific sample of ocean water.
The instrument looks like a drum to bongo does with a mouth opening that we know the dimensions of. This gets put into the software. I think they start at 40 centimeter mouth opening, and then it goes down into we call it a cod end. It's like a bucket where all the sample will collect.
The bongo nets look like two very long cones with big openings at the top, and the nets narrow down to a very small point at the bottom.
And the cod end, that's where the sample collects.
When they are pulled up from underneath the sea, they collect any creature that is bigger than the holes in the nets. And then, once the nets are back on board, they are hosed down so that everything inside rinses down the sides of the nets into a little jar that is screwed on at the bottom.
So if any plankton is stuck in the net, it will go into the cod end.
And then when that jar is unscrewed, the scientists can take it into the lab to process the plankton samples.
We have flow meters on there as well to measure how much water gets pulled through the nets. And from there, we can work out the amount of water that was used to collect the sample versus the amount of plankton. So we concentrate the sample because we have two nets. The one gets preserved in formalin and the other one gets preserved in ethanol. Formalin actually breaks up the cells, where the ethanol keeps the plankton cells whole still, so they can use those for identification under microscopes.
It was a very exciting day when I got to see some of the zooplankton, which are visible with the naked eye. They come in all different sizes. Some are really tiny and they just look like little specks in the water, and others look like little worms, little critters that are swimming around. They're almost translucent and they're actually very cute. Right, so we've heard about the CTD and bongo nets, which are deployed at specific points along the voyage to collect data for the scientists aboard. But there's also a very impressive piece of equipment that can collect data all year round, not only when the ship is off on a voyage. And that piece of equipment gets collected and deployed each time the SA Agulhas goes out to Marion Island. They are called moorings. If you've ever wondered how whale songs get recorded, this is how.
We've got two moorings that collect data continuously right through the year on an hourly basis. Each mooring has got a current meter attached to it, a temperature conductivity sensor, and a whale listening station or acoustic listening station. So the acoustic listening stations is used to identify throughout the year what whales is in this area and what season they do arrive. So that's quite new technology for South Africa. We're doing a lot of new research on these acoustic listening stations. It's exciting. The current meter, it measures currents right through the water column. It's a ADCP technology, it's acoustic Doppler current profiler, and it uses acoustics and the Doppler effect to slice the water into 8-meter bins. We call it bins or slices, and it will measure the current in each of those slices.
Right, so the mooring is this fancy piece of recording equipment that stays, thanks to the genius of ocean physics, at one point right near the ocean floor for an entire year.
So this is the only instruments where we get data right through the year on an hourly basis.
Just recording data, sounds, temperatures, currents, and more. But how does that mooring stay in place, considering that ocean water is constantly moving? Each year, the technical crew on the SA Agulhas II have to locate and bring back aboard last year's moorings and deploy the next year's moorings. Sometimes it can be a bit of a hunt, but luckily technology is available to help. Considering that these moorings are incredibly expensive pieces of equipment, not to mention repositories of valuable data, which is part of a growing longitudinal data set, we simply can't afford for them to get lost. This ship has a couple of other nifty scientific features, including a drop keel and a moon pool.
Because the vessel's icebreaker, it's got a flat bottom, and we've got a set of transducers mounted in the drop keel.
The drop keel records acoustic data that scientists can use to identify what species are in the water at the time of recording.
And the nice thing of the drop keel is once you're at sea, you can lower the drop keel down 3 meters below the vessel. This stops air bubbles getting in front of the transducers, which affects the transducers. And we've got 3 acoustic transducers in there, which is at set frequencies, and they can measure the fish and the plankton in the water acoustically. So we normally run those on the transits from Cape Town to Marion and on the return leg, because the bird observers and the mammal observers, they collect data during those transits. And then if they see feeding schools of birds or mammals, they would want to know what's in the water. And if you fine-tune the system, you can actually pick up species of fish, because they all got their own unique signal that they send out. Then we also got a ADCP, another current meter under the vessel, which we use for underway when we're steaming, to collect currents up to 500 meters down. It can do up to 14 knots and still get good data from that. And then there's a deep sea echo sounder, 18 kilohertz, which we're currently using to collect bathymetry data around the islands, just to map what the bottom looks like.
Bathymetry is the mapping of the ocean floor. The transducer emits a sound pulse that travels to the seafloor, bounces back, and returns to the ship, where it's recorded. South Africa is the only African country that has an Antarctic program and a scientific vessel with these capabilities. And this gives us a unique responsibility in this particular domain of science.
Yeah, the thing is, all the oceans are interlinked, totally interlinked. And the southern oceans with the circumpolar current plays an important factor because it crosses all the ocean basins. So it's important to know, are there changes happening in the southern oceans?
If you ever get a chance to visit the SA Agulhas II on one of its open days, I highly recommend it. So, on the ship, bags packed, in my cabin, I've met my cabin mate, and we left Cape Town Harbour. We sailed southeast, past the Atlantic seaboard and Hout Bay, as the afternoon lengthened. It was a perfect late autumn day. As the sun set, my last glimpse of land in the pinkish dusky light was the tip of Cape Point, and it was 5 days until we saw land again. And the land that we saw was Marion Island.
It's not quite like anything I've experienced before or have experienced again.
The first time I felt like a dream. When I came back, I kept on dreaming about the island.
What is this place? Over the Christmas and New Year's holidays in 1948-49, South Africa annexed 2 adjacent islands in the subantarctic ocean. The Prince Edward Islands, they were called then, and they are still called that today. Marion Island is one of these 2 islands. The other is called Prince Edward Island, and a permanent weather station was set up soon after the annexation. Since then, it's become an important site for scientific research and training for South Africa.
There's a specific plant on Marion called cochlear, and it's a fluffy little plant. It's generally very slippery to step on and grows in the areas where you try and work. But in the summer, that plant has a little yellow flower that comes out, and that flower smells like honey, and the whole area just smells like liquid honey floating through the air.
Marion is definitely a special place. Any tiny change we detect over this next year could be very important to seeing the future of the island, the future of other subantarctic islands.
When I went to Marion, I was still young and I was still naive. But then when I came back, it's a change that I can't really describe in words. But I was a changed person.
If it happens that I don't come for a few years, I feel it in my soul. I feel that something is missing. So it has become part of my life.
The Prince Edward Islands are a special nature reserve, which South Africa has committed to protecting. These islands are important habitats for top marine predators like elephant seals, fur seals, and penguins, as well as breeding sites for incredible birds, including albatross, petrels, and others. You'll hear more about all these creatures later in this season.
I couldn't imagine what would happen if the island got thrown off ecologically. If this island becomes a non-viable breeding ground, the effect could just cascade like that, on and on.
The islands can only be visited by scientists or those with permits issued by the South African government. No tourism is allowed. Prince Edward Island is entirely uninhabited, but Marion Island has a permanent research base where a couple dozen field scientists and technical maintenance experts live year-round. Once a year in autumn, the SA Agulhas II makes a voyage to resupply the research base, pick up last year's overwinterers, and drop off those who will be picking up the work for the following year. The research base on Marion Island is a relatively big building with common areas like the kitchen and dining hall, a games room, rooms and bathrooms for accommodation, and a number of laboratories to support the scientific work done there. It also has a weather station. Other than this research base, the only other buildings on Marion are a handful of tiny overnight huts for field scientists who need to spend a few days in the field.
My name is Eleanor Vademan. And for this voyage, I was volunteering as part of SAPRI, which is the South African Polar Research Infrastructure. Many of the top scientists in South Africa have spent time on Marion or been involved in some way. It's, I think, one of the most important programs in South Africa.
I looked at Marion Island a lot through my binoculars from the ship. It is incredibly beautiful, quite mountainous, with the highest peak reaching just over 1,200 meters above sea level. All the hills and mountains are volcanic, and the lower lying areas near the coast are covered in springy green foliage and lots of muddy mires.
It's surprisingly squishy, so you very much develop the muscles needed to pull your legs out of the mires. And then you're switching from the squishy to the hard black lava and then the hard grey lava, and it's only rugged terrain.
Walking around on Marion Island means that gumboots are an absolutely essential piece of gear. The coastline is made up of jagged black cliffs and rocky beaches.
Yeah, it's exhausting, but once you get island fit, you are just flying. It's so cool when you feel like okay, I can actually do this now.
It snows a lot, obviously. It's very cold that far down south. And sometimes the whole scene is covered in white, depending on whether that day's weather brought snow or not.
I'm Peter Cunningham. I was a SAPRI sealer on Marion Island. I think sometimes there's beauty in pain when you're caught out there in the snow and the ice rain caking over you. You just think, wow, that was quite an experience.
You might be wondering, what is the terrain and weather like on Marion Island? No one better to explain than those who've spent time there. Here is Khanyisa Makubalo, the team leader for the South African Weather Service team on our voyage. Their team conducted weather observations from the meteorological stations aboard the ship, and then they drop off team members who spend a year doing the same on Marion Island until they get picked up again in autumn 2026.
I'm a weather forecaster for the South African Weather Service. I've been there for about 3 years now. As the team leader, my main job is actually to facilitate most of the activities that we do here on the voyage, mainly doing a 24-hour monitoring and observations of the weather. We have to produce a product called a sign-up. So the sign-up has all kinds of data, so location of where the vessel is, your present weather, past weather in the last 2 hours, cloud types and the amount of clouds, temperatures, dew points, humidity. All of that kind of information goes into this. So the whole way to Marion, every 3 hours we have to do this. So we have a weather station at the very top of the ship. We've got an anemometer, which can then take wind direction and speed. We've got temperature sensors. We have pressure sensors as well. So we've got a barometer in the station. So all of that is collected into something called a data logger, which just transfers the information back to our computer at our lab, and then we are able to see the numbers. We also work with the ship for sea surface temperatures, so we are able to read from their SDS, and then we send all of that information to Cape Town.
One thing the meteorologists do is send up a daily weather balloon, which is exactly what it sounds like. It's a really, really big balloon that is sent up high into the atmosphere to collect data on the weather. These balloons were deployed daily from the ship, and they're also deployed on the island.
We release it once a day. We decided on midday here because of the weather conditions at night. It's quite dark, and also it can be quite windy and dangerous for us to actually go outside. We have a radiosonde, which is kind of a computer that will then read the weather outside. We have to put in gas onto that balloon so that it's able to get lifted into the atmosphere. Then you attach the radiosonde with a derailleur. It's just a tie between the balloon and the radiosonde. So the purpose of the upper A is actually to get the profile of the column of atmosphere as far as the balloon can go from the surface. We can get information such as the humidity through the different layers of the atmosphere, temperatures, winds, things like instability and stability levels, so to see if there's any thunderstorm that's possible to happen. So there's a lot. Upper A is quite an important instrument. Once that information is in, it's able to then run all of the math and the physics behind the models, and then you can get more resolution and better accuracies in terms of forecasting.
As you might imagine, the weather on Marion Island is pretty intense, so there's a lot of observational work for the meteorologists to do once they arrive.
The weather there is quite peculiar. You want to have some observations in the area for forecasting as well as for monitoring. So people would also use it for research as well as long-term data.
Kanisa explains what the work looks like on Marion Island for the colleagues that she left behind when we departed.
When we get to Marion, I just facilitate training. I'm actually going with 3 medtechs. They're called meteorological technicians. Their job is actually to do continuous observations of the weather. So when we get there, they then have to do a takeover where the old team, which was overwintering in Marion, is now training the new team. So they do a bit of practice as we're going there, and then when they get there now, they start to learn how to observe for Marion. So for those 3 weeks, they're doing a lot of training, showing them report writing, what they're supposed to be doing, maintenance of the station, maintenance of hardware like your computers, our hydrogen generator. So they go outside and they check what the weather is every hour. After that, they also encompass in the automatic weather station data and they do a sign up. And then if there's any activities like the voyage coming in and having flights as well, we do what's called a Mehita, which is just assisting with observations for aviation activities. They also look at the sea surface temperatures as well as swells to see what are the current conditions in terms of sea state, and then they also report on that.
The meteorology team on Marion Island feeds all their observational data through to the South African Weather Service in Cape Town, and that data is used for forecasting and to collect longitudinal data about the climate on the islands. So now that we know a bit more about the weather work that happens on the ship and island, let's take a closer look at the island itself. When did Marion Island form and how? To understand what that means, we'll need to talk to some geologists. Meet Professors Guillaume Delpech and David Hedding, both of whom specialize in the geology of subantarctic islands.
These islands are called oceanic islands in geological terms, and they are formed by internal forces which come from very deep in what we call the earth mantle, which is a layer that is below the crust on which we are actually walking. And this layer stands between, let's say, 30 kilometers down to 670 kilometers, and even down to what we call the core mantle boundary, down to 2,900 kilometers.
Okay, so the Prince Edward Islands formed from volcanic activity deep under the ocean. How old is Marion Island then?
So actually, we think that some of the magmas that actually form this island come from very deep and possibly down to the core mantle boundary. My name is Guillaume Delpech. I am a lecturer and researcher at the University of Paris-Saclay, and I've been teaching for the last 15 years.
Although we don't have an exact age, at around 500,000 years old, the islands are actually relatively young in geological terms.
Previously, others have done dating of how old Marion is, but what we've come to realize is it's not so important from an ecosystem point of view how old the island is. It's how old the surface of the island is. So because the island is volcanic, every time you have a lava flow, it literally resets the sort of ecological clock to zero.
And as Professor Hedding has explained, what's really crucial is understanding the age of the most recent layer of rock.
If you imagine the layers of a cake, the surface, the icing is what's important. And so we want to know the surface ages. Marion has got a very simple ecosystem. So you can use it in a lot of ecological models. But the problem is, if you don't know the ages over which that change occurs, those models don't really help you with much information. There's an older suite and a younger suite of lavas. And so we want to get an idea of the difference in ages between the two sets, because the older set was affected by glaciers, so when the island was covered in ice, whereas the younger set, we don't really have any idea of how old they are. And they cover probably 80% of the island. So it has massive implications for all the ecology and how we understand how the ecosystem of Marion works. By understanding the past, we can predict the future.
Have you ever wondered how geologists collect data?
So essentially, we collect rock samples
with hammers, sledgehammers.
Well, geologists like David and Guillaume have to enjoy hiking in rugged terrains, and they also have to enjoy carrying rocks in their backpacks for many, many kilometers.
The problem with most radiometric dating techniques is the younger the rock, the more volume you need to get an accurate age. So in some instances, if it's a really young rock that we think it may be only a few thousand years old, we need to collect far more in terms of volume than you would if it's a really old rock.
But they love it because they get to know very beautiful remote places like Marion Island, and also because they get to bring samples of incredible, interesting rocks home to scrutinize.
On a typical day, there'll be 3 of us in the field, and we generally try and target between 9 and 10 samples. Each sample is roughly about 1 kilogram, so we need to be very specific about where we sample. You don't want to sample the same lava flow twice.
Before going on the field, we study what we call geological maps. We look at the islands from the sky with the satellites so that we can look at the landforms, the geomorphology of the islands, and then we define areas where we want to collect rock samples.
We literally get to a site, we decide on a sample, we knock it out the ground, and then we put it in a bag and we seal it, label it, put it in a rucksack, and then we can bring it home.
We record their GPS position, precise location, and put little dots on maps. And
we take those rock samples back to a lab and we use radiometric dating techniques. In previous years, they used potassium argon dating, and now we're going to be using argon dating because it's far more precise in terms of the ages we can get. The more hardcore science, the cool chemistry stuff, then happens back in South Africa or in France. We'll probably be pre-processing these samples at the University of the Free State with Dr. Elizabeth Rudolph. We also use the University of Pretoria. They have a very fancy machine that essentially electrocutes the rock and separates minerals for us. We basically melt the minerals, and those minerals release gases, and we can tell a lot about the age of the rock from the gases that are released from a specific mineral.
It is quite difficult because I need to separate tiny little grains that I will select myself under a binocular. I need to crush the sample, and then once I have these grains, I will use what we call a mass spectrometer, which is an instrument that will allow me to measure the gas composition. So we have to take the sample to a higher temperature than 1,000 degrees, and the lava will melt again as when it formed originally. And that will release the gas inside, and measuring the composition of the gas will help me to understand how much gas has accumulated since the lava formed by what we call radioactive decay of some elements. Then I can calculate how old is this sample. Once we do that, we have a clear view of how long the volcanic activity took to build the whole island. Doing that comes back to what we call geochemistry, is getting the chemical composition of a sample. Basically, I will analyze every single element, or most of them, in the periodic table of elements, and from that composition, I can say many things about how the lava formed. Does it come from very deep? Has it stayed in a magma chamber for a long time? Have magma mixed between them? And particular chemical elements also help us to understand if they come from the very, very, very deep mantle, or if they come from more superficial area in the mantle.
Typically, the conventional thinking was that Marion was covered in ice until the last glacial maximum, which was roughly about 20,000 years ago. But Liesel Rudolph's PhD showed that Marion was deglaciated far earlier, so it's been free of ice for a lot longer than we thought. We want to know where and for how long those areas were ice-free potentially, but then covered in a new lava flow. And that has huge implications for the accumulation of organic matter to develop peat soils, and then influences when plants and insects would then colonize those areas. Many areas of Marion are probably a lot older than we've thought. I think the grey lavas are probably going to be about between 100 and 60,000 years old. From a geological point of view, that is like extremely young. But the black lavas are probably only 5,000, 10,000 years old. So they are even far younger.
This comes back to understanding basically how the Earth formed like 4.5 billion years ago and how it has actually evolved since then. By looking at the chemical composition of these rocks, we can understand how the Earth formed and evolved through time.
So, for example, on Marion, you get little springtails, and a lava flow could essentially separate to two populations of springtail. So you can get genetic divergence between those two populations of the same species. And it's those sort of interesting things that we can help the geneticists understand why there are these genetic differences between the same species on a very young island.
When we think about the beginning of the Earth, there was no continents. They were all oceans. So we also want to understand how the first continent formed, how the land masses actually accreted themselves to form big continents. And there is something in geology that is always applied. Processes that have happened in the past to form the Earth also happen today and will happen in the future.
Now, what about plants?
If you see a picture of Marion Island from afar, you think it looks actually quite barren and boring. There's no big trees, there's no big shrubs. The environmental conditions are stressful. Everything very short, small, short-statured plants. It's actually quite species poor in terms of the vascular plants. There's only 22 species of vascular plants on the island and quite a few invasive plants as well. There's 18 introduced plants on the island. But it's a lot of species of moss and lichen. So when you walk around the island, you're often crunching into these big patches. So they are the ferns on the island that are quite common. And just basically everywhere there's something growing.
Here is postgrad student
Nicola Marnovek
telling us more about the plants on Marion Island.
I think I'm one of the only people on board the ship who's got the plant ecology background and working on the plants. A lot of people forget about the plants, but I'm here to represent them.
You probably won't be surprised to hear that there are some very special plants on Marion Island which are unique to only that part of the world.
Azorella sulaga, the dominant cushion plants on the island, they find them pretty much everywhere. They stabilize the soil, so it's important for the other plants around them. A lot of the plants on Marion grow epiphytically, so they use the plant as a nurse plant to grow on it, and especially at the high elevations where it's even more stressful conditions, the Azorella helps to support these plants at the high elevations on the island.
The unique indigenous plants are under threat, not only from mice. You'll hear more about some very, very bad mice in the next episode, but also from invasive plants that were unwittingly brought along by human visitors over the past couple hundred years.
So often the invasive ones, they might not be able to withstand such stressful conditions. So sometimes you'll find them like in wind-sheltered sites. There's grasses that are quite successful. And then there's also this one that's quite widespread taken on the island. It's very short-statured. It's like mat forming on the island. And it can grow on the dominant cushion plants that are on the island. You often find it on there, you find it on the rocks. So they're quite resilient, they're hardy. They can tolerate actually quite harsh conditions. And that's what makes them successful invaders. The mice are also impacting the vegetation on the island. So I know we know a lot about the invertebrates and a big impact on them and the birds as well. But the mice are also impacting the plants, like the Azorella, the cushion plant. They're burrowing into it and often causing parts of it to die or the whole plant to die. And in fact, like I was speaking to people who've been onto Prince Edward Island, which is free of mice. And apparently when you walk there, you just find these giant Azorella plants, like huge cushions of them. But when you walk on Marion, they were around, but they were small, and often you see them dead and there's mouse burrows into them. So for my master's, I want to determine the impact of the house mouse on the vegetation of Marion Island, doing a comparison with the mouse-free Prince Edward Island. So going to be using vegetation plot data from these two islands as one component of my master's, and then hopefully I'm still working on this and wrapping my head around it, but using remote sensing and satellite data. So we can model the two islands, and we can pick up the differences in the vegetation because the islands are so similar climate, similar geology, similar vegetation. So big difference is the mice. Marion Island lying in the roaring 40s, it is very windy. So wind has an effect on the vegetation on the island. Wind is also an important climate variable that needs to be considered, especially with climate change, because wind speeds are actually predicted to change globally. And there's actually large areas of the world that are predicted to have an increase in wind speeds in the future. So for us to understand how wind's going to affect vegetation, we need to understand how wind currently affects vegetation before we can make those future projections.
So far, you've met our National Scientific Research Vessel and one of our special islands. Okay, let's zoom out again for a moment. All the voices you've heard were on the same big red and white ship that set sail from Cape Town with 3 blasts of its horn and headed south. We watched our familiar coastline recede into the distance and prepared for many days at sea. Some people got really seasick and hid away in their cabins. Others took seasickness medication and were fine. Some didn't get sick at all because they have their sea legs well earned. In the afternoon of the 5th day of traveling, word went around that land was in sight. Everyone rushed up to Monkey Island, which is the highest viewing point right above the bridge of the ship. There in the distance, we saw the charismatic shape of the western bluff of Prince Edward Island. A few minutes later, Marion Island came into view. These 2 small volcanic outcrops in the middle of a vast temperamental ocean. There we were, 45 crew, 100 scientists, technical and maintenance experts from 2 government departments and several universities, all together on this ship, finally arriving at our destination. Our ship, our island.
It connects you with nature, and it's something that on the mainland you can't really get. Because you can go and walk alone for a week, be in the heart alone. There's no traffic noise. It's just pure natural environment.
Very few people get to visit Marion Island. Tourism's not allowed, and only scientists and technical workers can apply for permits to do necessary research and maintenance work. As we arrived, I realized what a huge privilege it was to even just be able to look at these islands from the ship and to be a part of this really special voyage. In the next episode, we'll get to know more about the creatures that live on Marion Island, how they're being studied, and what we can do to help protect them. This podcast was created, recorded, and produced by me, Mehita Ikani, with massive production assistance from Andrew Burnett, who also did all the sound editing and sound design.
The opening jingle was designed by Victoria Landy.
My berth on the SA Agulhas II for the 2025 Marion Relief Voyage was provided by the South African National Antarctic Programme's Artists and Writers Project, directed by Professor Charne Lavery and Professor Jean Brundrit. I'm indebted to both of them for letting me step in as their writer-in-residence last minute and helping me prepare for the voyage at such short notice. Huge thank you also to Dr. Adrian van Eden-Wharton, who helped me get prepped for the voyage. She was the artist-in-residence in 2024. A massive thank you to all the guests who appear on this episode. Marcel van den Berg, Dr. Azuia Newu Makado from the Department of Forestry, Fishery and Environment, Eleanor Weideman, Yinhla Shiklo-Muchle and Peter Cunningham from the South African Polar Research Infrastructure, Professor Guillaume Delpech from the Université Paris-Saclay, Professor David Hedding from UNISA,
Nicola Marnovec from the University of Pretoria,
Kanyisa Makubela from the South African Weather Service. You'll hear from some of these lovely guests again in later episodes. The production of this podcast was funded by the South African Research Chair in Science Communication, of which I am the chairholder, which is funded by the National South African Research Foundation. The distribution and marketing of The Academic Citizen is done by Fumani Jwara. Huge thanks to the captain, officers and crew of the South African Agulhas II for keeping me and all fellow passengers on this voyage safe and well. To find out more about the South African National Antarctic Program, the SA Agulhas II, and the Prince Edward Islands, check out www.sanap.ac.za. Please note that all the guests on this season of the podcast are speaking in their personal capacities and are not representing the official views of any of the organizations mentioned.